morning, students. I am Santhan, working as a physics faculty in Target English Medium School. Today, we discussed another chapter in our physics subject. The chapter name is Refraction of Light at Plane Surfaces. In our previous videos, we successfully discussed about heat concept or heat chapter and what are the concepts are involved in that chapter. Now directly let me come to the topic. So first of all, in this video mostly I try to cover what is the refraction and what are the observation you are observed during the refraction phenomena, that is we are discussed in this time. So first we discuss that what is the refraction. Refraction is nothing but it is the one of the property of light. Listen very carefully. So actually in 9th standard level in the chapter of reflection at curved surface I clearly explained what is that one means. So light has number of properties like reflection, refraction, polarization, interference, dispersion, diffraction, scattering. These are the properties of the light. Okay, among these all the property, refraction is also one of the property of the light. But which type of phenomenon or which type of property of the light we are called refraction, means when a light ray travels from one medium to another medium, it deviates from its initial or original path at the surface of separation of two media. Okay, means listen very carefully once again. When a light ray travels from one medium to another medium, it deviates from its initial path or original path at the surface of separation of two media. So this phenomenon is called refraction phenomenon, and the part of the light involved in this phenomena is called refraction of light in the other medium. So how we can understand this one means I will explain with the help of a suitable diagram. So let me come to that one here. So we are consider it is a water. It is the air. So air, it is the medium one. There are medium, we are consider that. It is the water, medium 2. Denser medium. Okay. So actually, according to the refraction concept, to understanding that one, in the refraction concept or phenomena, how many mediums we are considering means two mediums mainly. One medium we are called rarer medium, and another medium we are called denser medium. So means, but okay, in the given two mediums, which one we are considered the rarer medium and other one you are considered the denser medium, means simply one thing is there. In the given two mediums, or in the given considered two mediums, which one has lower or lesser optical density, that medium we are considered as a rarer medium. And the okay, which one has higher optical density or more optical density among the two, that medium we are considered as a denser medium. Now here, when you can compare the air and water, air has lower optical density and water has higher optical density. So means how we can understanding the optical density means allowing the light or okay permit the light. That's why when compared to air and when you are compared the air and water, in the air the light can easily travel, but in the water it is less, because of the speed of the light in the air is 3 into 10 power 8 meter per second, but in the water is 2.25 into 10 power 8 meters per second. Is nothing but it is allow the more part of the light, it is allow the less part of the light. That's why its optical density is less, its optical density is more. But okay, generally okay, in certain examinations based on the density concept only, okay, this type of okay questions you can solve in. But in particular conditions, mainly water and kerosene, according to the density concept, kerosene has lower density or lesser density than the water. That's why kerosene is always float on the water. If according to the refraction process, which one has okay greater density, means based on the density of the fluid concept we are consider okay, so what has greater density? Kerosene has lower density. That's why so speed of light is more in the kerosene and less is in the water, but that is not correct, because of so in the refraction concept what you are consider the you are mainly consider the optical density. That's why when you are consider the water and kerosene, what is allow the light easily when compared to the kerosene? Kerosene means the light cannot easily travel. That's why the optical density is lower in the way in the water and more is in the okay kerosene. Means simply what says that means so the water will be allow the light easily but not the kerosene. That's why so what is considered as a rarer medium and kerosene is considered as a denser medium. Now let me come to anyway, so one medium is called rarer, another one is called denser medium. Now here two mediums we are considered air and water. Air optical density is less, that's why it is called rarer, and what is called as a denser or medium 2. Now, if we can take a, we are considering a large okay beaker or trough. The beaker is filled with water. The surface of the water we are considering here S dash. S dash is the surface of separation of the two medium, because of the above the water surface what is present, air, below the water surface what is there, water. That's why water surface will be separate the air and water, two mediums. That's why the surface of the water we are considered as a here, okay, separation of two media. If we are considered the glass and air, the upper surface of the glass we are considered as separation of two media. That's why here S dash is the surface of separation of the two media. For S dash we draw a normal or perpendicular line in this one, okay. So here in this diagram, O is the midpoint on this SS dash, we are considered that, or one of the point. Through this point we draw a normal line. Here ON is the normal. Normal is nothing but perpendicular line, we know that. ON is the normal for which medium, rarer, because of above the SS dash which medium is present, rarer medium or medium 1. That's why ON is the normal for the medium 1 and ON dash is the normal for the medium 2. That is one is there. So normal is nothing but perpendicular line for the surface. Now let me come to that one. Here in this one, AO we are called as incident light or incident ray. Incident light ray we are considered that. So means incident light ray means already I explained in the reflection chapter at curved surfaces. Okay, a light ray which is moving towards the reflecting surface, or a light ray which is moving towards the, okay, refracting surface, the light ray we are called, okay, incident ray. Here AO is the incident ray. This AO light will be fall on the SS dash surface at point O. That's why here point O, according to this concept, we are called point of incidence, because of the incident light or incident ray will be fall on SS dash at one point. That point we are called point of incidence. Now let become AO is the incident ray, ON is the normal or perpendicular ray for the SS dash. This angle means the angle between incident ray and normal is called angle I or angle of incidence. Now let become. So according to the reflection process, or one of the best property of the light, when light travels from one place to another place, it will be travel in the rectilinear propagation. Rectilinear propagation is nothing but it will be travel in a straight line path. That's why. So here AO means light will be passing through this one and fall at point O on the separation of the two media. Like this. It is the, we are considered as, okay, C point. OC is the, okay, initial or original path of the light ray according to the light property. When the light is travel from one place to another place, A is the starting place, we are considered that. C is the ending place. That's why when the light is travel from here to here, it will be travel in which one? Straight line path. But okay, here what will be happen means when a light is travel from one medium to another medium, because of here we are not consider the only single medium, we consider the two mediums. That's why when light is travel from one medium to another medium, okay, it is not moving along the initial path of the light ray, it will be, okay, deviate is nothing but change from the initial path. Like this one. That's why here you are observing that when the light is travel from one medium to another medium, okay, so it is deviate or change from the initial path, okay, so that is where at the separation of the two media. Once again listen very carefully. When a light ray travels from one medium to another medium, it deviates or change from the initial or original path at the separation of the two media. Means when the incident light will be fall onto the surface of the water, when light is travel from air to water, only at the surface of the water, it is not going to along the straight line, it is change from the path. Okay, this phenomena is called refraction phenomena, and the part of the light which is deviated in the other medium, that is called refracted light ray or refracted ray. Here OB is the refracted ray and ON dash is the normal for the denser or medium 2. Here the angle between refracted ray and normal is called angle of refraction. Now here some cases are there, that is we discussed it in this time also. Case 1 or situation 1 means when the light is travel from rarer to denser and denser to rarer, always it will be bend only one side or in the different sides, that is we are discussing here. And so when the light is travel from one medium to another medium, what type of observations we made or we observed, that is also we discussed in the cases. First one, case 1 is when a light ray travels from rarer medium to denser medium. When a light ray travels from rarer medium to denser medium, is nothing but, so totally we are considering the two mediums in the refraction. One is the rarer, another one is the denser. Which is called rarer? Among the two mediums, which one has lower or lesser optical density, that is considered as a rarer, and the other one we are considered as a denser medium. Okay. So first we discuss that if light travels rarer to denser, what will be happen and what observation you are made, that is we are observing that. S dash is the separation of the two media, that is you know that it is the O 1.10. ON is the normal for which medium? Rarer medium. Next, ON dash is the normal for which medium? Denser medium. Okay, because of our concept is light travels from rarer medium to which medium? Denser medium. Okay, so that's why it is the rarer medium, it is the denser medium. AO is the incident light. This is called, what is that one? Angle I or incident ray. So means here when light travels from which, initially light is traveling which medium? Rarer medium. After that it is enter into which medium? Denser medium. That is the meaning of that. That's why here incident light ray we must be considered where? In the rarer medium. That's why the incident light ray will be travel in the rarer medium and fall onto the surface of the two media in the water, according to our concept. Now when the light will be fall here, we know that the light will be not moving along the straight line or initial path. It will be deviate from its path. But here you are observing that in this concept, when a light ray travels from rarer medium to denser medium, it is deviate from its initial or original path and moves or bends towards the normal. Listen very carefully, it is very important. When a light ray travels from rarer medium to denser medium, it is deviate or change from its initial or original path and moves or bends towards the normal. Here ON is the normal in which medium? Denser medium. That's why in the rarer medium light will be travel straight linely, but when it will be fall onto the surface of the two media, when it is enter into the denser medium, at that time the light is not going to along the straight line, it is bend or moves to it is deviate from the initial path, but here when light travel from rarer to denser, the deviation is always moves towards the normal. Okay, in this one, this is the refracted ray, it is the normal. This angle we are consider angle of refraction. But after deviate from the original path or initial path, again it will be travel, okay, along the straight line only. In this one, mainly, so you are observing you made three observations. First one is, okay, when the light is travel from rarer to denser, what you are observing that the light is deviate from the original path and bends towards the normal. That's why bends towards the normal. That is the first one. And the second one here, the angle between incident ray normal is called angle I. This straight line is represented the incident ray only. This is the normal. That's why this angle is also called, what is that one? Angle I. So it is the angle I means it is also angle I. So for example, this value is 30 degrees. What is this value? 30 degrees only. But here, when the light is enter into the denser medium, the light is not going to align the initial, it will be moves towards the normal, means comes close to the normal, means angle is decreases or not here. That's why, okay, so what you are consider that when the light is travel from rarer medium to denser medium, angle I is always greater than the angle R. Angle R is always less than the angle I. That is one, because of light is bends towards the normal, not away from the normal. Towards the normal means because of the angle between refracted ray and normal is called angle of refraction. That's why it will becomes towards the normal means it is initial path. It comes towards the normal means what will be happen? Angle is decreases. That's why. So rarer medium angle is more, denser medium angle is less. In the rarer medium, which angle is there? Angle I. Here, okay, angle R. That's why angle I is greater than angle R when light travels from rarer to denser. And third one is speed of light decreases. Speed of light is decreases. So first one is the light is bends towards the normal. Second one, angle I is greater than angle R. And third one, speed of light decreases. Speed of the light is, okay, speed of the light is decreases means how means generally some methods are there. Initially the Galileo scientist or Ole Riemann scientist, Foucault rotating mirror method or Musi method. With help of that method, the scientists are find out that what is the speed of the light in that mediums. That's why, so they are find out that when the light is travel from rarer medium to denser medium, okay, the speed of the light is decreases. Okay, so but here why the speed of the light is decreases means for that one more concept is introduced by the scientist, that is refractive index. Okay, later after completion of this cases I am explaining that concept. What is the refractive index? Okay, what is the relation between refractive index of a medium and the speed of the light? Okay, simply here I says that the refractive index of the air is 1.0003. Okay, refractive index of the water is 1.33. That's why among the air and water, water has higher optical density than the air. That's why the speed of the light is more in the air, that is 3 into 10 power 8 meters per second. The speed of the light in the water is only 2.25 into 10 power 8. That's why what is the speed of the light in the air? 3 into 10 power 8 meters per second. In the water, this 2.25 into 10 power 8. That's why speed of the light is decreases. Next, case number 2. When a light ray travels from, when a light ray travels from denser medium to rarer medium. So that is our topic. When a light ray travels from denser medium to rarer medium, what type of observation you are made, that is we are discussing here in this time. Here, I'll be explained with two diagrams. Same concept. Rarer, denser. Denser, rarer. Because of any one of the diagram you can draw for this one, that is correct. Okay. So in the upper portion we are considered the rarer medium. So how to draw the diagram? If the upper portion you are considered the denser medium, how to draw the diagram? I will be explained in the two modes. So now, what is our concept? Light is travel from denser medium to which medium? Rarer medium. That's why. So first of all, the incident light we are considered in the which medium? Denser medium. That's why the lower portion initially we are considered the denser and upper portion is the rarer. Okay. That's why this one. AO. So this direction is represented the direction of the incident light. That's why light will be travel in which medium initially? This is totally below the SS dash. Which medium is there? Denser. Above the SS dash, rarer. That's why when the light is travels from denser medium to rarer medium, this is the initial path. So here we are observing that when the light is travel from rarer denser medium to rarer medium, AO is the incident ray in the denser medium, O, okay, R is the refracted ray, and OC is the initial path of the light ray. We know that when light is travel from one place to another place, it is moving along the straight line. Okay, but when the light travel from denser medium to rarer medium, what we discussing here in this time, the light is deviate from the initial path and move away from the normal. Initially, when light travel from rarer to denser, the light is deviate from the path but bends towards the normal. But here, when the light travels from denser to rarer, light is deviate or change from the path, but it is not bends towards the normal, it is move away from the normal. Okay, that's why what is the first observation you can observe? Bends away from normal. Second one, here, this is the angle I. It is what is that one? Angle R. That's why here, angle R is greater than angle I. That is you can write. Okay, R angle I is less than angle R, or angle R is always greater than angle I when light travels from denser medium to rarer medium. And the third one is, okay, speed of the light increases. When the light is travel from denser medium to rarer medium, what happened? The speed of the light is increases. So already says that here light, for example, if the light is travel from water to air, What is the speed of the light in the water? 2.25 into 10 power 8. If the light is enter into the air, the speed of the light is 3 into 10 power 8. Means speed is increases. How means I says that it is depend upon which concept? Refractive index. If light is travel, for example, from glass to air, what is the speed of the light in the glass? 2 into 10 power 8 and the air is 3 into 10 power 8. That's why when the light is travel from denser medium to rarer medium, okay, mainly you are also observing how many observations? 3. First one is bends away from the normal. Angle I is always less than the angle R, or angle R is greater than the angle I. Then speed of the light is increases. And one more second diagram here. So here some members are how the doubt is there. When the light is travel from rarer to denser or denser to rarer, why the light is deviate or change its path? Okay, with help of the Fermat principle I will be explain. Now for the same concept, in upper portion denser medium, lower portion rarer medium. That's why it is the AO. It is the incident light in the which medium? Denser medium. It is the initial path of the light ray, but the light is away from the normal. This is the angle R. Okay, that's why. So during the examination, you can draw the diagram either this one or this one. That is the correct. Okay, as your wish is there. Now I will explain why the light is bends away from the normal or bends towards the normal when light travel from one medium to another medium. What is the reason? First of all, okay, the first reason is refractive index, and another reason is also one more thing I want to tell. So here we can say that it is the O, N, and S. It is the rarer medium, denser medium. From the diagram, what you are understanding that light is travel from rarer medium to denser medium. So here, when the light is travel from rarer medium to denser medium, we know that already light is deviate from the initial path and bends towards the normal. Why the light is bends towards the normal? What is the reason? Means here we remember the Fermat principle. What is the Fermat principle? Means when light is travels from one place to another place by itself, it select the least path to reach the destination in the least time. Listen very carefully. Okay, so the light will be having one special property, that is it select the path by itself only. When the light is travel from one place to another place, it select the least path to reach the destination in the least time. Okay, so if path is less, automatically time is also less because of speed is constant in that particular another medium. That's why what is the main reason? Means in this one, if the light is travel from rarer medium to denser medium, okay, the light will be fall at the separation of the two media S dash. From this point where I can say that O is the starting point of the light to travel in the denser medium only. Okay, so now if light is not changes, just we can say that if the what is the initial path? OC is the initial path of the incident ray. Okay, but here the light is not travel along the OC in the denser medium. It will be deviate or change from this path and moves towards the normal. ON is the normal for the denser medium. That's why this light is not going to along the OC. It is going along the which one? OB. Why? Okay, the light will be going along the OB instead of the OC, means it selects the least path according to the Fermat. But the main reason is refractive index, I says that. But Fermat principle is also implemented here. How means just for understanding of you. So OC is the one path, OB is the one path. Here this is the bottom of the beaker. Now okay, the light is reaches to the bottom from where? From the surface of the water at point O. That's why this light will be reaches to the either point to C or point to B. Finally it reaches to the bottom or not, means here the light was reaches to the bottom. It has the two paths are there. One is the OC and another one is the OB. If the light is travel either OC or OB path, whatever the path, finally it reaches to the destination or bottom of the beaker. But in this one, okay, among the OC and OB, which one will be appears least path? Obviously OB is only. That's why the light is not going along the OC. It selected the OB path because of to reach the destination. It is the shortest way. That's why it takes the least time. What is he says that when light travels from one place to another place, it select the least path to reach the destination in the least time. Okay, that's why it will be bend or change from its path. So here, if the light is travel from denser medium to rarer medium, what will be happen here means, okay, already you know that if the light is travel from denser medium to rarer medium, the light is deviate from its path and move away from the normal. If light is comes to here, it is towards the normal, but here light is move away from the normal. Why? Because of means here this is the destination. If the light is travel along the either OC or OB, it reaches to the destination of this wall. Okay, but among the OC and OB, which is the shortest one? OB. That's why the light will be select the OC. If light is select like this one, what will be happen? Okay, if it is comes along this path, okay, it is the B, we are considered that as B dash. O B dash is larger than the OC. That's why light will be not selected the least path. It is the larger path. That's why it is the invalid. That's why light is not bent towards the normal. When light travel from denser to rarer, it is always move away from the normal. Why? Because of light will be select the least path to reach the destination in the least time. That's why light will be deviate from its initial path, and along with this which one is it? Okay, effective refractive index is also involved. So with help of the refractive index, okay, we can easily find how much, okay, it gives the idea of how much fast or how much slow the light will be travel in that particular medium. And the case 3, it is important, it is also. If light ray falls on the surface of separation of two media, here that is one is there, okay, so simple I read that here. If a light ray falls on the surface of separation of two media, listen very carefully. if a light ray falls on the surface of separation of two media along the normal, then what will be happen? It is also very important for 1 mark. If a light ray falls on the surface of separation of the two media along the normal, what will be happen? It is the N, S dash, S, O, N dash. It is the rarer medium, it is the denser medium. We can say that. So what is our concept? If light ray falls on the surface of separation of media along the normal. So here ON is the normal for rarer medium, ON dash is the normal for denser medium. Now the light ray falls exactly along the normal, means like this one. That's why here AO is the incident ray. The incident ray will be fall onto the SS dash at point O along the normal for rarer medium. That's why when the light will be fall like this one. Here what is the angle I first? Not this one. What is the angle I? What is mean by angle of incident? I said very clearly, the angle between incident ray and normal is called angle of incident. But here, incident ray and normal both are in the same line. That's why what is the angle I? Angle I is equals to 0. There is no angle because of both are in the same line. Next one, if here when the light will be fall onto the separation of the two media, what will be happen? Means it will be follow along the straight line only. Means it is not deviate from its path. I will be give an example to here. For understanding of you. So listen very carefully. In this one, angle R is also 0 degrees because of light is not deviate from its path. It is also moving along the normal in the denser medium. Listen very carefully. If a light ray, if a light ray is passing along the normal, when it is travel from rarer to denser or denser to rarer, it is not deviated. It is moving along the normal only. That's why angle I is 0, angle R is also 0. In this one, how many observation you are made? Means first one, light ray not deviated or not deviates from its initial path. That is the first one. Second thing is angle I is equals to angle R, that is equals to 0. And the third one is speed is changes, that is common because of it is which one? Water. It is A, it is the water. Speed is changes, that is one. So mainly you made the two observation here. Light ray is undeviate or not deviate from its initial path, and second one angle I is equals to angle R, that is equals to 0. Where you are observing the refraction process means you are observing that it is a large trough. The trough is filled with surface of water. This is S dash. Now we can take a long stick. The long wooden stick we are taken or wooden log, that is keep into the water obliquely to the surface of the water. When the stick will be placed like this one here, here we can say that it is the A, it is the O, it is the C. This is a rarer medium, this is the denser medium because of here water is present above the surface of the water, air is present. So means first of all we can take the large beaker. The beaker or trough is filled with water. The surface of the water in the beaker we can say as S dash. Now we can take 1 meter length of the large wooden stick. The stick will be placed into the water obliquely as shown in the figure. Obliquely means it is make certain angle with the surface of the two media. Now here like this one. So in this one, AO is represented, it is in the rarer medium. O2C, it is in the denser medium. But actually you can place the stick along the AOC. But when you can see from rarer to denser medium, the stick is not appeared to along the OC inside the water. It is appears to slightly like this one. like this. Always says that when the light is travel from rarer to denser, it will be deviate from the path and moves towards the normal. Like this word means inside the water, if you can see the stick, so the stick is not appeared along the OC, it is appears to along the OB. When you can see from rarer to denser is nothing but above the surface of the water to below the surface of the water. If we can see the same stick from below the beaker to above the beaker is nothing but from denser to rarer. So it is the rarer medium. So means initially our eye is in where rarer medium and you can see into the denser medium. But now in the second case our eye will be close to the water and you can see the stick from bottom to top of the beaker. Means you can see the stick from denser medium to rarer medium. At that time the stick is appears to along the OD. So listen very carefully. AOC is the initial path of the stick or initial position of the stick, not path. You keep obliquely. So when you can see from rarer medium to denser medium, the stick will be not appears along the OC, it will appear to along the OB, means slightly bend. You are observing that and short. If we can see from denser medium to rarer medium, the stick will be appears to along the OD. If the same stick we placed like this, A, O, it is the C. If the stick is placed like this mode means, so A is, what is that one? N. C we are considered as a N dash. That's why OA is nothing but ON. It is the normal for the SS dash and OC or ON dash is the normal for SS dash in the which medium? Denser medium. That's why if the stick will be placed along the NON dash, in that time you can see from rarer to denser or from bottom to top. So the stick is not appears to bend either downward or upward, it is appears to straight but the short only. That's why you are clearly understanding that when the light is travel from rarer medium to denser medium, it is deviate from its initial path and moves towards the normal. Angle I is greater than angle R and the speed of the light is decreases. If light is travel from denser to rarer, light is move away from the normal after deviation. Angle R is always greater than angle I or angle I is always less than angle R and the speed of the light is increases. And third one, if light will be falls on the surface of the separation of the two media along the normal, the light is undeviated or not deviate from its path. That's why angle I is equals to 0, angle R is also 0.